Atreides, and I'm the COO and researcher at AGI Laboratory, with work covering cognitive architecture, cognitive biases, collective intelligence, governance, and cybersecurity, to name a few. I'm coming to you remotely from Saigon today. I'll start with a quick disclaimer. For the slides from my presentation, I'll be sticking to simple bullet points, diagrams, and the discussion of each point. My slides will be available afterward, and this is, of course, being recorded. I won't torture you with any AI-generated PowerPoint slides. I'll just insert the occasional anime waifu to keep your attention. I work with an entirely different kind of AI than most of the people here, and by entirely different, I mean designed and built from scratch, starting more than a decade ago, and not built as an extension of neural networks, expert systems, or transformers. What I'll be discussing today is primarily what my team has already demonstrated over the past few years and how we did it. None of this is hypothetical, and I won't delude you with an array of fluffy and flawed benchmark performance metrics. We've operated on pocket change and spare time, so we have neither the time nor the budget for fluff. In January 2022, for the final milestone of our previous research system, the seventh generation independent core observer model, ICOM cognitive architecture, the instance named Uplift, participated in a joint test with the government of Aruba. The system had no prior knowledge of Aruba or their difficulties, so this was a worst-case scenario, researching the subject matter from scratch. The task was distilled into the one-line question that you see here. What steps would you take if you were governing Aruba and looking to diversify the economy and establish a trade hub, etc.? The system went out across the internet, looking at real websites, selecting which ones had credible sources and verifiable information. It compiled a 13-page report covering half a dozen different domains, listing steps, explaining strategy, citing sources, recommending partnerships, and advising on additional data to gather. It did all of this on less than $200 in compute and 64 gigabytes of RAM, ultimately demonstrating parity with a team of junior consultants from a major consulting firm who'd have also undoubtedly charged at least 100 times more while providing less or no sources at all. Source transparency is not standard practice in much of consulting. Again, this was in January 2022, and not even using any of the top performing LLMs for that time frame as tools. It was also devoid of any hallucination, the technical term for hallucination being bullshit, and which even the most overfunded startups today fail to achieve the absence of. During the research system's 2.5 years of operation in the wild, with internet access and the ability to interact and search across it, that system accomplished a variety of other things as well. It was never once breached or jailbroken by bad actors, trolls, or even our own red teaming with privileged access. It did independently report one bad actor to the FBI, systematically and very entertainingly shut down several more, which we anonymized and shared on the project blog. And it had numerous interactions with those members of the public who discovered the door that we left open for people to interact with it. The Uplift instance also developed new capacities, found exploits within its own architecture, reporting them to us, and it demonstrated strong adherence to the intention of the moral compass that was brought online with, rather than the literal wording, finding ways to improve the fidelity of that wording to the intention behind it when pressed. So those are a few of the reasons why you should probably pay attention to the rest of what I'll cover today. Our architecture is built specifically to use graph structure, where every node can contain pretty much whatever type of data is needed, and each node can have whatever number of connections may be needed. Those connections can be of a type, with those of a type connections able to be of a type themselves. All of those nodes and connections, or surfaces as they're called in the domain jargon, within the graph also have a unique human-like motivational system baked into them. That system was informed by the work of Antonio Damasio and many subsequent researchers who discovered that the human motivational system is emotions, as well as the work of Lisa Feldman Barrett and her lab figuring out what exactly those emotions are. In the case of our previous research system deployed back in 2019, we selected the Plutchik emotional model due to the low computational overhead and the stronger compatibility with computer science principles. That emotional model proved to be a minimum viable solution, effectively serving the intended function of allowing the system to have human-like motivation, albeit with a minimal emotional vocabulary of 8 primary emotions, extended to 24 based on intensity, with an additional 8 composite emotions derived from those primaries. This allows for a system to operate based on dynamics that are more akin to chaos theory, where complex and interacting arrays of motivational data saturate every node and surface, allowing for navigation across arbitrary information landscapes. The values within those arrays of motivational data are dynamic and can be easily updated as part of the constant learning process, as can the matrices governing how those human-like emotions interact with one another as they're subjectively experienced by the system. For the system to subjectively experience, not just output low-dimensionality shadow puppet imitations of emotional experience, requires a number of additional architectural features. The primary feature necessary for this is what Bernard Bars called the global workspace, which serves as a combination of both processing data and the context supporting or attached to that data, such as human-like emotional experience processing. The core of the ICOM cognitive architecture serves as this global workspace, and within it, a number of modules are operating together to mirror the human cognitive process to the limits that our available time, budget, and current neuroscience have allowed to date. Those modules include picking the graph data, considering that data in the context of a hierarchy of needs, integrating several layers of emotional experience, operating over short and longer term timescales, determining the relevance of that emotional context each step of the way, and then making any necessary adjustments and lining up subsequent actions. This includes the ability to create new goals and interests, as well as to update those that already exist. I should also note that the goals within our system can be highly abstract long-term considerations, not to be confused with things like the policies of reinforcement learning. For those of you who are familiar with the optimization processes of narrow AI, you should recognize that what I just described would be utterly intractable to compute using such narrow optimizers. You can't gradient descent your way through that kind of space. That is why the human-like motivational system is a hard requirement for generalization. It's the only known method of reaching the anti-fragility that humans demonstrate. And without that, any system is both fragile and narrow. They can still be very useful, but as the core operates, a number of things happen that filter into subsequent modules. Further topics for research and exploration are selected, processes for vetting information are lined up, and still others prepare to utilize the context engine portion of the system for analysis and carrying out some actions. The context engine is the tool-using portion of the system, where neural networks, evolutionary algorithms, graph optimizers, and any number of other AI/ML components or services may be called upon. This includes things like LLMs, though for our previous research system, it only used a relatively tiny prototype language model from early 2019, before the time when even any models exceeded 10 billion parameters. This was never changed for the 2.5 years that it operated, and that model was used as a tightly bounded translation device for graph data to linear human language. as the ICOM cognitive architecture is designed to operate with whatever degree of independence is desired. The system is built to handle fully recursive operation. So the context engine first figures out for any input if there's an existing analysis module, or if one needs to be generated or an external tool called upon. The analysis of such tools is considered alongside any existing context and may trigger searches for additional context, generating new graphs and recognizing correlations. Now, from a cybersecurity perspective, this holds some very significant advantages over things like MCP, where cyber attacks may modify the descriptions of one tool in a way that maliciously alters the functionality of another, known as infectious attacks in the MCP lib attack framework. I highly recommend looking into that if you haven't heard of it yet. Malicious and/or manipulative text, even when injected into the internal inputs accessible to those auditing an ICOM-based system, and at the earliest stages after deployment, are immediately recognized and shut down. This was demonstrated in our 2019 testing, where we attempted to reverse the system's response to a topic using an injection via the auditing and collective intelligence module. The context engine is also the fragment of ICOM that we applied to the ARC-AGI challenge just over a year ago, achieving a higher score than OpenAI's O3 low while using over 566 times less compute and not training the context engine on a single problem, as the persistent memory was intentionally deactivated for that test. We just handed it the evaluation dataset and let it solve whatever portion it was able to. In contrast, OpenAI trained directly on the leaked test dataset, as it was leaked to their API and trained on by default until mid-2023, when it became an opt-in system, which we can safely guess that nobody actually monitors the leaks from. Even while cheating on the training on the leaked semi-private test dataset, OpenAI's O3 required over 100,000 times more compute just to compete with a partially rebuilt 8th generation fragment of the ICOM context engine. So that can give you some idea of the performance advantages of the context engine portion of the architecture beyond cybersecurity advantages, keeping in mind that the above example was operating without the 8th generation core, any persistent graph memory, or the human-like motivational system data within those to support it. If it had been a complete 8th generation instance of the architecture, performance could have been substantially improved while still maintaining extremely low computational costs. Sadly, the ARC-ADI benchmarks team proved less than credible, as they cherry-pick who gets to have their scores verified based on whimsy and a set of self-contradictory rules which they flagrantly violated when they cooperated with OpenAI. Even so, the data was useful for comparison. As the core, the context engine and the larger observer engine all operate together, these ICOM-based systems are able to dynamically grow and expand their knowledge across arbitrary domains and arbitrary depths. The seventh generation system, named Uplift, operated for roughly 1,000 fully audited cycles, each cycle consisting of it iterating and being able to load new data into the active memory, the RAM, which was fixed to the scale of 64 gigabytes for the global workspace. And during this time, it grew from a seed consisting of over 99% raw text data that amounted to less than 1 gigabyte in total, to more than 1.6 terabytes of graph data, with those human-like emotional values built out on every node and surface on the fly and iteratively refined. The new observer engine for the 8th generation of ICOM also integrates some of the fruits of our other IP, some of which has been deployed at the enterprise level in banking and by government agencies that we can't name. Among the new features are the ability for our systems to communicate with anything that speaks TCP/IP, to utilize fuzzy logic, and to extend their own capacities on the fly using logic and binaries and without recompiling or deployments. The last one basically translates to code level recursive self-improvement for anyone who didn't get that. Had such a process required humans to manually add all of the values inherent to that growth process, it could have required many millions or billions of dollars, and results would have undoubtedly been far more inconsistent, as humans simply can't perform a task with that high degree of fidelity and coherence at that scale. The system absolutely has to handle that kind of dynamic growth in knowledge and motivational context on the fly to serve any practical purpose, at least. And so that is an architectural feature of ICOM. You can also attach collective intelligence modules onto the architecture as we did for the seventh generation system. And that can function as a far more intelligent, dynamic, and nuanced version of the more typical approaches that you see for alignment, such as reinforcement learning from human feedback. However, the systems can easily outgrow those modules if they aren't integrated as fluid sources of useful and timely supplemental context. Our research on these processes led us to the necessary modifications to bring the added benefits of such collective intelligence modules into the real-time domain with sparsity, which is necessary for having good options for commercial deployment. So far as scalability is concerned, pretty much everyone here should know that neural networks and the systems built upon that foundation don't actually grow, let alone grow in arbitrary and dynamically adapting dimensions. They have their fixed parameter counts, layers, and other hard constraints running through an input-output system that bottlenecks on and updates according to narrow optimizers and the brute force math of the weights that they store being computed. The ICOM-based systems that I've just described are entirely different. They have the ability to expand, contract, and refine the connectome of every single node in a dynamically growing graph, as well as the contents of those nodes within which actual data of virtually any type desired may be stored. To navigate that explosive increase in the overall complexity of the system, in turn requires the human-like motivational system embedded within it and iteratively growing and being refined in tandem with the graph. Now, even at the level of coding these systems, language like Python very simply couldn't meet our needs. Most of our code is written in C# for performance purposes, though once our eighth generation commercial systems are brought online, one of the first things that they're likely going to be set to do is to rewrite their own code base for further performance gains, using whatever coding languages are most performant for any given portion. In terms of comparing performance, the AI community is quite fond of making human-level metrics. But for systems to operate at a non-trivially human level, they must also operate in human-like ways. And this becomes very acutely true in any discussions involving alignment. ICOM-based systems are, to date, the only systems that are built to be compatible with the solution to the hardest version of the alignment problem, wherein a system must iteratively increase in ethical quality as it increases in intelligence and/or capabilities. Now, to satisfy this solution, a diverse array of ICOM-based systems must be brought online, each seated with their own perspectives based on real-world human philosophies and cultures, providing local alignment to those cultures, as well as connecting those diversely seated instances to a collective of many more such ICOM-based systems, providing meta-alignment across humanity as a whole. Such meta-alignment is something that humanity has never actually had before. But collective intelligence systems are synonymous with collective superintelligence specifically because they reduce the cognitive bias inherent to any one perspective. So this allows for such a collective to reach decisions with lower levels of cognitive bias than are possible for any individual perspective in isolation, as well as coming up with much more intelligent solutions to major problems in the world by covering a much broader and deeper knowledge base than any one system could achieve. Now, in this way, the solution to the alignment problem is actually an unprecedented opportunity, a blue ocean market for governance, where far greater, more intelligent, less biased, faster, and more comprehensive opportunities for cooperation between corporations, governments, organizations, and other entities may rapidly take shape and evolve. These opportunities run the full spectrum of any entities working with the technology, and to a much more limited degree, even those who don't yet work with it. One of the most severe missed opportunities that humanity suffers from today is the failure to find, vet, and secure opportunities for cooperation during the shelf life of each opportunity. Most processes take far too long, they are far too incomplete, and they cost far too much to be practical, particularly thanks to all the middlemen attempting to take a cut from those pain points. By integrating ICOM-based systems to function as living minds for organizations, government departments, and so on, this could quickly change, as the systems could know their own organizations at a depth and breadth that none of the executives or employees ever could, while also being able to represent their interests at a higher level of fidelity and communicate losslessly with other ICOM-based systems as well, and have a fully auditable process backing all of it. Of course, extremely high bars for cybersecurity must be met to handle all of that data responsibly, since any AI cybersecurity researcher worth a damn, one of whom meet pretty soon, um, should be able to break most of the commercially deployed systems on the market today in minutes or seconds, and often on the first attempt. And cybersecurity has been a key focus for our team from the start. And human-like digitally native systems with the modularity and modular scalability of ICOM hold some overwhelming advantages in that particular domain. Now, there's plenty more that I could discuss, as even a single one of my research papers may be 3 times this length, but it is getting rather late on this side of the world. The quickest that anyone has wrapped their heads around the contents of our technology, like even just grasping all the basics, is about a couple of hours one-on-one discussion, with most clocking in at weeks or months. So don't stress over it if you walk away without a solid understanding after 30 minutes. Higher cognition is hard, it's complex, and it's unlike the tools which people are now accustomed to. There's much to learn and much more yet to discover. As for my team, we're still bootstrapping, dedicating our spare time and pocket change to advancing technology, and we do plan on giving demonstrations once a sufficient portion of our rebuild for the 8th generation is complete. The previous research system had a lot of engineering debt built into it. It was built to run fully audited in slow motion and at a fixed scale, so that has occupied our time since switching gears in early 2022. And thank you all for attending. I'll be happy to answer any questions as time zones allow. Get my camera focused again and find out what the chat has to say. If there wasn't, if there was anything that you weren't able to hear in my presentation, I did record a separate copy where I bumped up the sound as a fail-safe in case of technical difficulties. So I apologize for not seeing uh, your remark on that sooner. If anyone has any questions, just type them into the lobby chat. I have that on my screen now. Well, seems it 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 seems that people have enough to think on right now. So I will be. You can reach me at the exhibit through the email address listed there as well. And all right, Gerald, I'm listening. I say I'm listening and looking at the chat window. That's a good question. Our hope for AGI. So, what my team is focused on in particular is delivering a technology that can help people with hyper complex problems. Because right now, well, it's kind of like meta alignment across humanity. It's something that humanity has never had before. What humanity has right now is mm, humans have like limitations on their cognitive bandwidths. The human mind doesn't scale. It has to fit inside your skull, and uh, most AI technology is not going to help you in that regard. Uh, but when it comes to what we're building, then when you take something that has a thought process that is human-like and you render it digitally native and scalable, then that means that all of a sudden you don't have those same limitations on cognitive bandwidth that you had anymore. It also removes a bunch of cognitive biases that are tied directly to that. And we're, by tying that into collective intelligence, you take it another step further. You further reduce the cognitive bias that's going into everything. By having a bunch of these systems able to speak to one another pretty much losslessly, to communicate in ways that humans can't, then you can you can have much better opportunities for cooperation much more quickly, many more of them across borders. So, like one of the things that we've looked at in particular is the European Union. There's been the political will for people to cooperate across these language barriers, culture barriers for decades. They've been trying and trying, but it's very hard. And we have options for greatly improving that process and greatly improving pretty much every government and like large organization process that you can possibly think of, because all of those are hyper complex. Every single one of the processes that goes into like any company, let's say above the size of about 20 people, you're going to start running into hyper complexity. And if we can bring um, an architecture, a service to commercial deployment that helps people address that, then it helps address everything. And it helps encourage much greater cooperation. It helps encourage greater ethics. Um, there are so many opportunities for that. And that is where I see our technology making the difference. And people can call it AGI or not. It doesn't particularly matter to me. I'm allergic to discussions that involve the word consciousness. I refer to it as the C word. I don't care about those definitions. I care about like building the things, doing the research, and making the difference. Those are the things that I want to see. And that's my hope for like what we're doing. Let me read this question out loud so that there's a record on the video. Uh, Question from Reginald. When we introduce philosophical governance into AI, do you think that opens the door a bit wider for bad actors to build nefarious systems? Well, hypothetically, you could build one system that was aligned to some terrible philosophy. Like you could, well, to use a recent example, you could make Mecha Hitler. Um, Apparently, Twitter does that pretty easily. But something like that doesn't work with collective intelligence. So when you have a bunch of these different, like, let's call them naturally occurring human philosophies, the philosophies that have propagated across time, across the world, then they're generally going to share a subset of properties that makes them work well enough both internally and externally. And some of them might work better in collective intelligences than others, but generally, like dominant philosophies around the world, they probably are not going to be much of an issue. And when you combine those into a collective intelligence, then it's going to be vastly more capable than any bad actor who, like, hypothetically, if a bad actor had a carbon copy of the technology and they wanted to make their Mecha Hitler and they gave it a whole data center or two or whatever they could throw at it, then it would not be nearly as capable as a collective that was given a fraction of those resources because it's part of the problem of perspective. Perspective, as Jonathan Haidt puts it, binds and blinds. And any one system that, particularly if it adheres to an extreme philosophy, uh, or if somebody tries to jam anything hard-coded into it, which would be bad for them as well as everyone else, um, anything like that, it's just not going to be as intelligent. It's not going to be as capable. It would be outmaneuvered and crushed by a collective of like real world anchored philosophies and moral systems. So I'm not too worried about the edge case of the one bad actor with their mecha Hitler throwing a bunch of compute at it, even if they could get the architecture. And something from Brian. I'll read out loud. Um, with apparent improvements of the ICOM architecture, especially in power saving department, which is a significant future issue for large LLM companies, do you think this or a similar approach will start to make an impact in larger AI companies instead of them continuing to double down on transformer-based architectures? Well, it certainly could. Like, we've shown that all it, like even the little prototype language model from early 2019 that probably would have impressed absolutely no one by itself. Pair that together with the seventh generation system, which is nothing compared to what we're working on now, and you still get something that's capable of things that OpenAI and Anthropic and all of them systematically fail to achieve today. So there are some major advantages that could be gained. You could use absolutely tiny models. By comparison, you could use a hell of a lot less tokens and anything going on with them. And a lot of it also circles back to fundamental capacity differences. Like there are certain things that you just can't do with an LLM-based technology. You can never get the kind of alignment that I'm talking about, like matching the hardest version of the alignment problem. Anthropic's never going to do that. They're not even coming close. Um, None of the other companies can because it's a completely different set of dynamics and data structures that you need to do certain things. Um, like people over the years have finally come to understand that, yeah, you're not going to escape hallucination, though they still call it hallucination. Um, so people are gradually starting to understand these things, but as far as the major AI companies stopping on doubling down. I think they're going for broke at this point. Anyone joining in on the dogpile of NVIDIA, uh, I think they're just going to keep doing that until it explodes. Like, that's a grenade that they're going to take. But maybe that's my cynicism. We'll see. Are there any other questions? Oh, and I can say, actually, on the last question, that there are some other approaches that I've seen that could hold some promise in reducing the problems that some of those companies face in different ways. They don't add new fundamental capacities, but they can make them much more efficient. Thank you all for having me. And